All right, this is take 3, and hopefully this will be the last time I have to go through this. But our main goal is to make sure you understand the process of actually drawing the residual plot for your project. And then I do want to talk to you a little bit about what the residual plot actually shows and tells us and how we can interpret it. So I came up with a set of data, I just made it up. And I've plugged that set of data into the calculator. I actually decided I wanted to take a quick peek at what it looked like on the graphing calculator. I'm also going to refresh your memory on how you find the least squares regression line and put it in there. But you're going to do that by hand. And there's my equation. So I've got my equation written in here from what the calculator told me. And what we find is that that correlation tells us we have a strong negative relationship. So we want to go through the process. You're actually going to want to draw your graph by hand. It's too hard to actually try to do the process by transferring from the graph. So I've put the points in here that are from this particular graph. And I am going to eyeball the least squares regression line, but you're actually going to go through the process similar to what you did with the Vitruvian man. So choose an x value that is low, like x equals 5, and plug into your least squares regression line and graph that point. Choose a value that's high, plug in for x, solve for y, graph that point, and then play connect the dots. I'm actually, like I said, gonna kind of do this by hand. We tend, as I shared with you all, we tend to draw these a little too steep. And we also tend to draw them a little bit higher than we should. And I definitely did that on this case as well also. But it'll work for what we've got to do. So I do want you to see visually what the regression line looks like on the calculator. So let's go back and look at that. So if we go to menu and analyze and regression and show linear, so that shows what the line should look like, and that's my eyeballing attempt. All right, so I want you to keep in mind what the process is and what we're actually doing or finding when we compute and find residuals. So visually, I want you to think about what's happening, and that is that we are looking at and considering specific x values, and at those x values, we are considering what is the difference in the y values between the actual point and what the predicted point is from our least squares regression line. So at 7, if you see, we've got this very small distance. The line goes very close. At the value of 8, we've got a little bit farther distance, just as we did at 5, and so on. So the distances here are very close. And if you notice on the graphing calculator, there are some that are above. Some of these points are above, some of these points are below, and that changes and affects the overall value of our residual. So if we have a residual that's positive, think about the fact that that means we are looking at points that are above the least squares regression line, and if we have a negative value, we are actually looking at values that are below the least squares regression line or lower than the predicted value. Okay, so above the line, if they're positive, the actual value is larger than the predicted one, and if they're negative, that means the actual value is lower than the predicted. All right, so to go through the process of actually finding those values, we're going to use our table of points, and we know from our table of points what our x values are. So we have these given x values, and we have to figure out, so these y values here are our actual values. For our y's, and we need to come up with what the predicted value is. So keep in mind that process on the graphing calculator. We're gonna go to this computation page, And our first X value that we want to plug in, where did I put this? Our first X value that we want to put in is 5. So if we do F1 of 5, oops, you can't see that. So F1, make sure you remember to open the parentheses and put 5 in there, and we get that value of 49.3. And if I do F1 of 7 and hit enter, I find that that value is 45.9. So to compute our actual residual, we're actually doing actual value, which was from our table of values, these points. So actual value minus predicted value, so 50 minus 49.3, and we get 0.7. And then 44 minus 45.9, and we get negative 1.9. And so these are our residual values, and they correspond to the X values that we have in our table. So at 5 for this X value, the residual is 0.7. And so on. So I did all of the work here. So these are our residuals. And now we need to talk about how we actually create that graph. So we're going to use these particular points. We draw a little bit different type of graph. So here's what the graph looks like to draw a residual plot. So for our residual plot, we're going to have our x-axis. And if you notice, we have to have some positive and negative because our residuals are positive and negative. Some of the distances are above the least squares regression line, some are below. So to graph our residual plot at each of the indicated X values, we are going to plot what the residual is. So at 5, the residual value was 0.7. At 7, the residual value was negative 1.9. At 8, it's a positive 1.8. At 10, we find that the residual value is negative 0.85, so that's about right here. At 11, it's at negative 0.15, so that's just below. And at 12, it is at 0.55, so it is just above. So this is how we draw and create our residual plot. I'll share a little bit more in the next video about what it all means and how we all put this together.